I greet you everybody out there. You are welcome to Mr. Ola James TV at Number Sentences. Now, today we are looking at simple trigonometric, as in we are trying to introduce, a ratio that has to do with triangle. Now, let us look at it. We have three names in consideration. The first one is hypotenuse. And the second is adjacent. And the third is opposite. Oh, we need these three so to be able to what? To talk about the sides of the triangle, especially right angle triangle. Now, what is hypotenuse? Let's quickly take that definition. Hypotenuse is the side of a right angled triangle that faces the right angle. It is the longest side. It is the longest side of the triangle. Now, listen, with this definition, you will know that hypotenuse is the only one here that has a fixed side. Now, hypotenuse is the side of a triangle that faces the right angle. This is the right angle. The side that faces the right angle is the hypotenuse. It is always the longest side of the triangle. So anytime you see a triangle like this, this is the hypotenuse. This is the hypotenuse. Always is the longest side, and is the only side that have its name fixed. It maintains this position. It goes nowhere. But these other two, adjacent and opposite, they change position. Based on the angles under consideration, based on the angle we are interested in, based on the angle that is, in view. Now, when we are defining the adjacent, you see what I'm talking about. What is adjacent? Now, adjacent, this is a side of a right angled triangle that joins the hypotenuse to form the angle under consideration. Can you see? Let's look at it. If this is the angle under consideration, look at it. This is hypotenuse. The only line that has joined the hypotenuse to form this angle is this one. So this is our adjacent now. Adjacent. This is the adjacent. But let us see another triangle here. If you have this triangle, this is our right angle. This remains the hypotenuse. This remains the what? The hypotenuse. Now, we are taking this angle, theta. Now, the side that joined this hypotenuse to form this sin theta is this one. So this is now our what? Our adjacent. Look at it. Here is this side. Now is this one. We can call this one now. The adjacent is the height here, but no, the adjacent is the length here, or the base. That is what it is. Now, just know that the angle under consideration is one that tells us where will our adjacent be. So if adjacent can take this position or take this position, depending on the angle we are talking about, then opposite to we have to shift place. Let us look at the definition of opposite. Now, opposite This refers to a side of a triangle that faces the angle under consideration. The angle we are considering, the angle in view, the angle we are talking about. Here, look at it. We are talking about alpha here. The side of this triangle that is facing alpha is this one, opposite. So they don't drag space with each other. Adjacent and opposite don't drag space with each other, but they know when to switch position. They know when to switch position. The only one that the position is fixed is the hypotenuse. Hypotenuse is always the longest side, is the one that faces what? The right angle in the right angle triangle. But this one here, the angle under consideration is theta. Theta is the angle under consideration. So the opposite is the side that is facing the theta. The opposite is the side that is facing the theta. So here, this is the opposite now. Opposite. Now, with this few explanation, you can now see that it depends on the angle that we are considering before you can get your opposite and adjacent placed in the right side. Now, this is adjacent here. This side here, it's same as this side here, but adjacent is there, opposite is here. Why? The angle under consideration, the angle we are looking at, the angle we are searching for, or the angle we intended to use. Don't forget, adjacent is the side that joins the hypotenuse to form the angle under consideration. This is angle under consideration. It was this line that joined it to form this angle. Then that will be our adjacent. I believe that is clear. That is very clear. Sine, cosine, and tangent. Sine, cosine, and tangent. Now, when you look at this one, what we normally use for them is we take the S of this one, we take the C of this one, and we take the T of this one, sine, cosine, and tangent. And we replace them with a kind of formula to help students to be able to understand what we are talking about. So we call this one so, we call this one ka, and this one toa. So that's from so ka toa, is to be able to help so that we can learn how to apply this very well. So when sine is to be used, it is when we have, let's say, let's put sine theta, cos theta, tan theta. So this one now, look at it. Sine. In sine is O and H. This O is representing opposite. H hypotenuse. A adjacent. H hypotenuse. O opposite. A adjacent. Now sine theta. Let's take it. Let's get the one that we use theta so that we don't start messing up with alpha. Now this one, sine is opposite over, what is that? Hypotenuse. So that is that. Cos theta. We are still using this theta. That is adjacent. This is adjacent over hypotenuse. You can see I am using this SOHCAHTOA to relate my formula over there. Yes, let us look at TOA now. TOA, that is tan theta. O is opposite over A is adjacent. This needs to be well understood before we go, angle of elevation and depression, so that you'll be able to understand how to use this, because we can actually use this trigonometric ratio. We call this one trigonometric ratio. Once you have known how to apply your adjacent, hypotenuse, and opposite, how to place them where they're supposed to be, then you must know this ratio as well. We call it trigonometric ratio. SOHCAHTOA is going to help you. It's just a simple language I can just say SOHCAHTOA. When you list it out like this, you know this is sine. Sine equals to opposite over hypotenuse. Cosine mean is equal to what? Adjacent over hypotenuse. And tan is what? Opposite over adjacent. So, and this is what we have here. So we have to learn this very well first, assimilate it, digest it, before you can be able to go to angle of depression and angle of what? Elevation. And also in bearing too, we can use this to solve bearing case. Apart from sine rule and cosine rule and tangent rule, we can use sine rule to solve bearing. We can use cosine rule. We can use tangent rule. Depends on which one the question says or the one we will. This is very simple. Just go over the video again and again and again, and I know you are going to get it. It is very simple. Get how to name your triangle and get this ratio into your head. Thank you. God bless you.
Oh, you are still with me, Imano. So when we pray, when we cry,